Hi there, dear students. For math lesson today, we are going to delve into the world of calculus and specifically discuss the importance of definite integrals. The definite integral is an base concept in calculus that is used in many real-world applications. It allows us to calculate area, volume, and solve complex math problems that we wouldn't be able to solve otherwise. Before we start the lesson, be careful. There is a link for exercise of this lesson down below at the description. Download it. And if you're new, please subscribe the page and push like button. Write your comment if you have any comment. Definite integral. We will learn how to use the antiderivative to find the area of region bounded by the graph of the function, the x-axis, and the two lines x equal a and x equal to b. Integration of fx dx when f is a derivative and x is a variable of derivative. B is called upper limit and A is called lower limit. Be careful, for every example must be A less than B or A smaller than B. It equal F capital B. F capital B is antiderivative when x is equal b, minus f capital A, when f is antiderivative the function when x is equal a. Be careful, we use the same rule of the indefinite integral. The area of A bounded by the graph of the function f of x, the x-axis and the two line x equal a and x equal b is, if we have the graph of this function at the interval ab over x-axis, this area is positive, so it is equal, area is equal a integral from a to the b fx dx, which equal f of b minus f of x. Example 1. F of x is equal x cubed. Find the area of the region bounded by the graph of f, the x-axis, and two lines x equal 2 and x equal 4. As we see at the graph of the function, the area is over x-axis, then it is a positive area. Then this integral is equal, or this area is equal, integral from 2 to the 4 x cubed dx. And now we are taking the integral of x cubed by adding 1 to the power and dividing by a new power, which equal x to the power 4 over 4, from 2 to the 4. First of all, use the upper limit, which is equal 4, and substitute it at place of x. It's equal 4 to the power 4 over 4. After that, minus and substitute 2 in place of x, which become 2 to the power 4 and over 4. Simplifying is equal 64 minus 4, which is equal 60 unit of area. Find the area of the region bounded by the graph of the function f of x is equal sine x, the x-axis and two lines x equals 0 and x equal pi. Before we start this solving this question, first of all, we must know if the area is positive or negative. To know that, we must take a value for x between 0 and pi. Let be pi over 2. After that, substitute pi over 2 at the fraction f of x. It becomes sine of pi over 2. Sine of pi over 2 is 1. 1 is a positive number, so the area is positive. Draw the graph of the function like this. As you can see at the graph of the function that the area is over x-axis, so it is positive area. Then the area is equal integral from 0 to pi sine x dx. It equal minus, because the integral of sine x is minus cosine x from 0 to the pi. After that, we substitute pi in place of x. It becomes minus cosine pi minus, after that we are substituting 0 at the place of x. It becomes minus cosine 0. As we know, the value of cosine pi is minus 1, so it becomes minus 1 minus, this is this one minus 1 and this minus. The cosine of 0 is 1. Simplifying, it become 1 plus 1 is equal 2. If we have integral from a to a, that means if the upper limit equal to the lower limit, then this integral is equal to 0. For example, integral from 2 to 2 is 0. Integral from minus 1 to minus 1 is 0. Integral from 0 to the 0 is 0. If the upper and the lower limit are equal, then this integral is equal to 0. Integral from b to a. As you can see here, b is bigger than a. So we can take the integral. We must change this interval from smaller to the bigger. So we write minus from a to the b. That means the integral from b to a for fx is equal minus integral from a to the b fx dx. Third one, integral from a to the b fx dx is equal integral from a to c f of x dx and integral from c to the b fx dx when c is belong to the interval AB. If we have any number between A and B, we can solve this integration by making it into two parts. Fourth, integral from A to B k f of x dx. That means if we have a constant number multiplied by a function, we can take this constant number outside of the integration. It becomes x integral from a to b f of x dx. Or we can say we haven't any work with the constant, only taking the integration of the function. Integral from a to the b f of x plus or minus g of x dx. Here we can take this integral by taking the integral of each function alone. First of all, we are taking the integral of f of x from a to the b dx. After that, if we have a plus, we add addition, we make it add, or if we have a minus, we will write minus, and then taking the integral of g of x. If f is the continuous function and f of x bigger or equal 0, f for all x in AB, then if we have the integral of a function which is over x-axis, which means it is positive, from the interval a to the b, then this integral or this area be positive. So area is equal from a to the b f of x dx, it's bigger or equal to 0. If the function is over x-axis, then the area is be positive or the integration must be positive. If f and g are two continuous functions and f of x bigger or equal g of x for all x in interval ab, then if we have two functions, one of them is bigger than the other, as you can see here, f of x is over gx, that means f of x is bigger than gx. Therefore, the integration from a to the b for f of x is bigger the integration from a to the b for gx. That means the area between f of x or bounded by f of x and the x-axis at interval ab, it is bigger than the area which is between g of x and x-axis and at interval ab. So integral from a to the b f of x dx is bigger or equal the integral from a to the b g of x dx. If f is the continuous function, then f capital X is equal integration from a to the x f of x dx is a differentiable function in the neighborhood of a, and its derivative is f prime of x is equal f of x. The function f of x, capital F of x, is equal a integral from a to the x f of x dx is called the cumulative function. Integration from 2 to the 4 x squared minus 3x minus 2 dx. First of all, we must take the integral. The integral of x squared is x cubed over 3 minus the integral of 3x is 3x squared over 2 minus the integral of 2 is 2x from 2 to the 4. First of all, we are substituting 4 in place of x. It becomes 4 cubed over 3 minus 3 times x 4 squared over 2 minus 2 times 4. After that, minus substituting 2 in place of x, it becomes minus 2x cubed over 3 minus 3 times 2 squared over 2 minus 2 times 2. Simplifying, 4 cubed is 46 over 3 minus 4 squared is 16. 16 divided by 2 is 8. 8 times 3 is 24 minus 2 times 4 is 8. And 2 cubed is 8 over 3 minus 2 squared is 4. Cancelling 4 with 2 is become 2. 2 times 3 is 6 minus 2 times 2 is 4. Simplifying this one is become minus 32 over 3 plus 22 over 3. It become minus 10 over 3. Example 2. Find the value of each definite integral. B from minus 1 to 3 minus absolute value x minus 1 plus 2. If the integration contains the absolute value, we find the value of x which makes the inside of the absolute value 0. So take x minus 1 is equal to 0 and x is equal to 1. And if this value x is equal to 1 belong of the interval of the integration, which is minus 1, 2, so we must take this integral into two parts or make it into two parts. Because here we have 1, the sign of x is positive. Bigger than 1 is positive and smaller than 1 is negative. And now we are defining the function, or first of all we must take the absolute value f x minus 1, absolute value x minus 1, it is negative, that means minus x minus 1. Here it is positive, x minus 1. Because before the absolute value we have minus, so multiply all these by minus. It becomes minus absolute value of x minus 1 is equal minus times minus, it is positive, it remain x minus 1, and here minus times positive x is minus x, minus times minus is positive 1. Because we have the absolute value, added 2 for it, so add 2 for all of them. It becomes minus absolute value x minus 1 plus 2. Here x minus 1 plus 2. Here minus x plus 1 minus plus 2. Simplify, it becomes x plus 1 when x is less than 1, and it is minus x plus 3 when x is between 1 and 3. So the integration from minus 1 to 3 for absolute minus absolute value x minus 1 plus 2 dx is equal the integration from minus 1 to 1 when the function is x plus 1 dx, and from 1 to the 3 the function is minus x plus 3. And now by taking integration, x is x squared over x plus 1 is x. After that, minus x is minus x squared over 2 plus 3 times x, and substituting the value 1 and minus 1, 3 and minus 3, minus 1, it becomes 1 over 2 plus 1 minus 1 over 2 minus 1 plus minus 9 over 2 plus 9 minus 1 over 2 plus 3. Simplifying, it becomes equal to the 4. First of all, we must take the integral. It become x squared become 1 over 3x cubed minus 2x 1 over 3. By substituting 4 in place of x, it become 1 over 3 4 cubed minus 2 times 4 minus, and now substituting minus 2 in place of x, it become 1 over 3 minus 2 cubed minus 2 minus 2. Simplifying, it become 12. The value of integral may be positive or negative, but the value of the area always is positive. We have here in this question absolute value. First of all, take inside the absolute value equal to 0, so x is equal to 0. Because x is belong in this interval, so we must change this integration into two parts. First of all, from minus 1 to 0, the second one from 0 to the 4. Because before x is positive, so bigger than 0 is positive and smaller than 0 is negative. We are defining the absolute value. Absolute value x is here is minus x and here is x. Because we have minus before absolute value, so multiply all of them by minus. It becomes minus absolute value of x. Here minus time minus is become positive x. Here positive time minus, it is minus x. After that, adding 1 for them is 1 minus absolute value of x, 1 plus x, 1 minus x. So the function between an interval minus 1, 0 is 1 plus x, and the function in interval 0, 3 is 1 minus x. And now the integration is equal. Integration from minus 1 to 0 for x plus 1 dx, and the integration from 0 to the 3 is 1 minus x dx. And taking the integration and substituting the value, and now simplifying, it becomes minus 1. The mean value. The mean value of the function f over interval ab is the number 1 over b minus a integration from a to the b f of x dx. Theorem 5.2. The mean value theorem for integral. If f is continuous function over ab, then there is a value like c belong to the ab when f of c is equal 1 over b minus a integration ab from f of x dx. Example. Find the mean value of the function f of x is equal 3x squared minus 2x over the interval 1, 4. Mean value is equal 1 b minus a, that means 4 minus 1, integration from 1 to the 4 f of x dx. It becomes 4 minus 1 is 3, integration. In place of f of x, we substitute 3x squared minus 2x, and after that, take the integration. 1 over 3, 3x cubed over 3 minus 2x squared over 2. And now, cancelling 3 with 3 and 2 with 2, it remains 1 over 3 x cubed minus x squared from 1 to the 4. Substitute 4 in place of x, it becomes 4 cubed minus 4 squared, and minus after that substitute 1 cubed minus 1 squared. 1 cubed is 1, 1 squared is 1, 1 minus 1 is 0, so this part is 0. It's become 60. Find the mean value of the function f of x is equal to x plus 1 over the interval 1, 4. The mean value is equal 1 over 4 minus 1 integration from 1 to the 4 f of x dx is equal 1 over 3 integral from 1 to the 4 2x plus 1 dx. By taking the integration, it became 2x squared over 2. Cancelling 2 with 2 remain x squared, and the integral of 1 is x. And now substitute the value of 4 is become 4 squared plus 4 minus 1 over 3 x 1 squared plus 1. Be careful. Every time rewrite 1 over 3. 1 over 3 minus 1 over 3 when you are substituting the value of x in place of x. Simplifying, 4 squared is 16, 16 plus 2 is 20, 20 over 3 and 2 over 3. 20 minus 2 is 18 over 3, which is equal 6. Question. If the mean value of the function f of x is equal a square root of x over the interval 0a is equal to square root of 3 then the value of a is equal 3, 2, 4, 5. The mean value is equal 1 over a minus 0 integral from 0 to a x square of x dx is equal for 2 square root of 3. And now, by taking a from inside the integral to outside and simplifying the way is become 1 over a times a, cancelling a with a, so it remains integration from 0 to a and converting square root of x to the power 1 over 2 dx is equal square root of 3. And now by taking the integral of x to the power 1 over 3 is x to the power 3 over 2 times 2 over 3 from 0 to a. And now replacing a, when we are replacing a, it becomes 2 over 3 in place of x, write a to the power 3 over 2 minus, when we are replacing 0, it becomes 0, equal to 2 square root of 3. And now simplifying is 2 over 3, a to the power 3 over 2 is equal to square root of 3. And multiplying both sides by 3 over 2 to cancel 2 over 3, it becomes a to the power 3 over 2, 3, and this one 2 is cancelling with 2 and remain 3 times square root of 3. And taking the power of 2 over 3 to cancelling this power for both sides, then this one is cancelling with this one and cancelling these two ones. So a is equal 3. That means a is a correct answer. Here we reached the end of the lesson. Thank you for watching, and please do not forget that there is a link for exercise of this lesson down below at the description. Download it and subscribe the page and write your comment if you have any question and push like button. Thank you again and goodbye.